Let's get a quick overview of the computer parts. These are the components of any modern computer. This is a sort of an older picture. Some of these are not present on your laptops. We have the CPU, which stands for Central Processing Unit. That is responsible for the computation. So that's sort of considered to be the brain of your computer. We have the memory, which stores data. The CPU has an internal memory as well, which they call cache, which also holds data. There are multiple locations where data is kept. So when you store a number in a variable, that information has to be kept somewhere. It has to be written somewhere inside your computer. And there are multiple places that can happen. It can be in the cache, it can be in the memory, it can also be in your hard drive. Hard drive is a permanent data storage place. The memory, another word for memory is RAM, and your CPU cache, they are transient in the sense that if you run out of power, if you don't have a battery and you just unplug your computer, everything that's in the memory and the CPU cache are gonna get wiped out. When you restart your computer, starts fresh again, any data that you had there is lost. The advantage of the memory and the CPU cache is that they are very fast to access. They're also more expensive. The typical RAM on your computer is several gigabytes. 4 gigabytes is the average on your laptops nowadays. So that's how much RAM your laptop has. Your hard drive is typically, say, 256 gigabyte is the average laptop hard drive capacity that you guys may have. Okay? And this ranges from, say, 128 to 1 terabyte. RAM is fast, cache is much faster, and they're also more expensive. It would be better to have more RAM, but adding an additional 4 gigabytes of RAM is going to cost you a lot compared to adding, say, 1 terabyte of data. So hard drive is cheaper than RAM, but it's also slower than RAM. When your computer first starts up, your operating system, Windows or Mac, has its own data, its own programs, its own apps. All of those are contained in the hard drive. That information is transferred to the memory. Your hard drive is 256 gigabytes. This one is, say, 4 gigabytes. We cannot really load everything that we have on the hard drive. That would be slow and not necessary. So only the parts on the hard drive that are required for your computer to run efficiently are loaded into the memory. Okay, so only the things that we currently need will be loaded into memory, such as, say, if I run my Word program, the Word program will be loaded into memory. Excel program, when I'm not running it, will remain on the hard drive. Memory is a place that we are mostly using when we program. So when we create a variable C equals A plus B, this creates a variable C. It is going to be stored electronically somewhere within the memory. So as a place in the memory, some bits in the memory will contain the number that we store in C, let's say 11. So that number 11 will be stored inside the memory. It's not going to be stored in the hard drive. Hard drive is where the files are kept. If we, say, store the number contained in C into an Excel file from our code, that's when we would push it to the hard drive. But when we don't do that, everything stays in the memory. The memory is a linearly addressed system. That means every box, every location in the memory has a linear address. You can think about it as one giant stack of boxes. This is going to be my first box, second box, 4 billionth box. When we store C equals 11, Matlab will have to negotiate with the operating system to sort of claim a place within the memory and store this number there. The memory is used by all the programs on your computer. The operating system is what manages which program is allowed to access what portion of the memory. So Matlab manages that transaction for us. It will claim a portion of the memory for us for our variable C, and the number that we have will be stored there. Sometimes we may have data that doesn't fit into a single box. Matlab will then, in the background, claim 2 consecutive boxes or 3 or more to allow us to store everything we need to store in that location. We may have a variable that's not just one number, but a vector or a matrix of numbers. Matlab will claim enough space from the memory and store the information there. It's a linearly addressed system. Every box in the memory has a number associated with it that represents its address. And that detail is managed by Matlab and the operating system. In other programming languages, such as C and C++, sometimes programmers deal with these addresses in the programming language. But in Matlab, it's sort of in the background. Okay? That's automatically managed for us. The motherboard is where all of these things are plugged in. The video card is a connection between your CPU and your monitor. Plug in your monitor into your video card. The video card would have its own cache and also its own CPU, or many CPUs, which we call GPUs, graphical processing unit. Working with images is a computationally intensive task. And those operations, rather than doing them on the CPU, they are mostly done in the GPU, which has a specialized architecture to handle images more efficiently than the CPU can. Your video card may have multiple GPUs contained in it. It's sort of multiple little brains that can process an image more efficiently. The image can be separated into multiple chunks, and each little brain of GPU can handle one chunk of the image. So when you watch a movie, that information is taken from the RAM and sort of processed in the GPU video card and displayed on the screen. As I explained, there are different levels of data storage. You have the CPU cache, the RAM memory, and the hard drive. And CPU cache is the fastest. RAM is the second fast, and the hard drive is last. The speed increases as you approach CPU. The cost also increases. So it's more expensive to increase your cache rather than to increase your hard drive. Information that is currently being used would be loaded into the faster cache that's closer to the CPU. And when things change there, they would be pushed back to, say, the hard drive if you want to save them. And the operating system manages that for us mostly. But when we program, sometimes we may have to deal with how things are stored in the hard drive and how things are stored in the memory. Now let's review some of the operating system conventions that we sort of implicitly used in our discussion of setting up Matlab. My computer and your computer would have one or more hard drives, one or more physical hard drives, okay? On Windows, you can view them by right-clicking on this PC and selecting Manage. On Macs, you can run the app called Disk Utility. Don't make any changes unless you know what you're doing. In this computer management, I'm going to go into Disk Management, which will list the physical hard drives that are installed on my laptop. If I plug in a USB drive, that's also considered a physical hard drive, and it would appear as a separate drive here. Okay, so let's say disk 1. They are numbers starting from 0 on Windows. Each hard drive is partitioned into virtual drives. So these chunks are sort of how my physical hard drive is separated into different parts. I have dedicated this portion to be my C drive. I have dedicated this portion to be my D drive. The other portions are hidden from me. They are used by the operating system when our computer crashes. It may have to pull out, recover things from those partitions. So we're not going to be using them in this discussion. On Macs, these hard drives would appear as a slash, which is the root drive, slash users, which is the user's drive, and things like that. So on Macs, a drive, a root folder are sort of the same thing. On Windows, we have these letters followed by a colon, which represent the top level of the folder structure. So that's a big difference between Windows and Macs. On Macs, everything starts with a slash. On Windows, everything starts with a letter colon slash. And then from that top level, we have a hierarchical folder structure. Things are inside other things. That's why it's a hierarchy. When you navigate into a folder, we are navigating through that hierarchy. On Windows, we have the program called command prompt. So you can open that. On Macs, we have a program called terminal. So open your Spotlight by doing Apple space and start typing terminal. That will locate the terminal app and you can run it. So this has a command prompt, which is just an indication of after that we can type our command. The command prompt on my Windows shows which folder I am in. On Macs, it may show you the username and which folder you are in. In this command prompt, we can run other programs. One program is dir on Windows and ls on Macs. So if you're on a Windows machine, just type dir. It will list the contents of the folder we are in. If you're on a Mac, type ls and hit enter. It'll show you the contents of the folder. These programs take additional options. One program is cd, which has a similar meaning as what we used in Matlab, change directory. We can move into any folder we would like. So cd users, like that. This is my cd program that I'm running. This is the input, the argument I'm passing into the cd program. When I type cd, that information is sort of taken by this black window program. Command window program takes what I typed, cd, interprets it. It's another program I'm trying to run. It will go locate it on the computer and pass any arguments I have to that program. Run that program, get its output, and show me in this black window. That's what goes on behind the scenes when you hit enter. If this black window doesn't know where cd is, it will not be able to run it. Let me give you another example. So if I type Matlab and hit enter, it does not know where it is. So it takes my text Matlab. It doesn't have any program that it can pass this on to. Okay? So it doesn't know what program I'm trying to run. This black window terminal has a list of folders that it would search whenever I type the name of a program. So I type Matlab, it's going to go through that list of folders, see if there's a file called Matlab in there. That list of folders is called the path of my environment. So path environment variable contains a list of folders, let's say C program files, C Windows, and things like that. When I type Matlab, the black window terminal We'll go through these one by one. Is there a MATLAB there? No. Is there a MATLAB here? No. Is there a MATLAB executable there? No. If it cannot find it, it will return and complain to me. One option I have is to, rather than typing MATLAB, I can explicitly write down the full path of this program. This is where my MATLAB is. C program files MATLAB R2018B. And within that, I'm going to go into the bin folder, which is where the MATLAB executable is located. When I type MATLAB in the black window, by convention, the Windows command prompt will search for matlab.exe. I can be more explicit and type matlab.exe, which would be better. So I'm going to provide the full path, which means starting from the root folder, I'm going to do C program files, MATLAB, / and so on. When I hit enter, it's not going to work. The problem here is it uses the space character as a separator. I have C program, that's the first thing that it will use. So if the command prompt thinks that I am trying to run a file C program, which doesn't exist. If it did exist, this would become an argument, an input argument that it will pass into that program. The very first thing is the program it is running. Everything else after that are the inputs it's going to provide to that program. I can enclose the whole thing in quotes to enforce this to be a single thing. And now it's running MATLAB. You can pass in additional arguments that MATLAB program understands, but we're not going to do that here. You typically don't deal with this to run a program because you usually run a program by following these menus or typing MATLAB in the search bar. The Windows operating system, that start menu or your spotlight menu, handles that search for you. But sometimes even that may not be sufficient. All right, let me go back to this matlab.exe. As we discussed, the command prompt doesn't know where to find this. An alternative solution to specifying the full path is to make sure that my path environment variable contains an entry that is this folder. So if I keep C program files MATLAB to 2018B bin, one of the folders in my path, then the command window, when it searches through those folders, it will locate the MATLAB app. You can change your path on Windows or on a Mac. You can search Google for how to do that. I'm not going to discuss that now. We're going to discuss it as it refers to MATLAB functions. There are differences between the command prompts of Windows machines and Mac computers. Some of the commands that are available on Macs are not available on Windows. I'd say Mac has more uniform and sort of useful terminal compared to Windows, which is, for historical reasons, they haven't really done a good job, I'd say, as compared to Mac. Mac has borrowed the command prompt from another operating system called Linux. So it's sort of well established. The commands are very useful in that terminal. There's a program called Cygwin that when you install it on your Windows machine, gives you a command prompt that is very similar to a Mac terminal. So if you're interested in playing around on a Linux-like environment, you can install Cygwin on your Windows machine. The next concept I would like to go over is environment variables. When you open a program on your computer, each program would have some environment variables associated with it. Each variable would have a name and content. One of the environment variables is called path, as we discussed last time. When you open command window in its environment has a variable named path. And when you type a command, it goes over that list of folders and tries to find the program that you are trying to run. There are other environment variables such as temporary directory, which determines where on your computer you would like to store temporary files. There's another variable called home, which represents your documents folder or your home folder, your users folder. Okay. On Windows, these are available in a Windows command prompt. If you type env on Windows, it will list all the environment variables and their values. So there's the path, then your username, your temporary folder, all of those are listed here. If you are on a Linux or a Mac machine, you can again type env and get the list. On Windows, it's actually set. The format of the output is different between set and env. Env is a Mac program, set is a Windows program. On each line, you see a different variable, the name of the variable followed by an equal sign, and its value. These environment variables affect the behavior of the program that's currently running. Every program that you start borrows, inherits the environment variables from the operating system. The program itself can change these environment variables. You can change them before you start that app. Okay. On Windows, if you want to change your environment variables, you can do that by going into your computer properties. Right-click on this PC, properties, and advanced system settings. And then from there, you have environment variables. Changing environment variables is not recommended unless you know what you're doing. It can break the way that your computer runs, and your computer may not respond properly if you don't follow the correct format for these environment variables. Okay? So we're not going to play around with that. But if you wanted to be able to run Matlab just by saying Matlab in the command window, you would have to change the path in your operating system through that interface and add the folder containing Matlab executable to that list of folders on your path. The options that you set for your programs are kept in different locations on your computer. For example, on my, say, Word document or PowerPoint, if I don't like my PowerPoint to automatically change 1/2 to a different format, or if I say third, sometimes when you type it, RD will be automatically superscripted. There are some options that you can change in the app that you are running. Those settings are kept depending on the operating system you use and depending on the app you use. They have their own choices. They are usually kept in a registry database on Windows and in flat files on a Linux system. On Windows, if you type regedit, it's again sort of an advanced tool. Don't make changes unless you know what you are doing. Regedit is the name of the program that allows me to view and change that registry database. The options in this registry control how my computer runs, how I want my folders to look like, what my desktop background is, and for each app, how I would like it to behave. There's a large number of options contained in here. And it's a hierarchical structure. You have settings for the entire machine, regardless of which user is currently running it. You have a folder for each user. So if you have multiple users on the computer, you and maybe your friend or your sibling, you can create multiple users on a single computer. They would each have their own folder where these settings are contained. Windows manages the structure of this registry database, and it maintains it on the hard drive so that when you shut down your computer, you can still have the same settings. Let me turn it back on. On a Mac or on Linux machines, the settings are kept in a folder called etc. Computer-wide settings are kept there. So let's go in there. Change directory /etc takes me to that folder on a Mac. And I can list the contents using ls. On Windows, that command was dir. These files control how some of the programs behave on my computer. So I have a program called SSH. These files contain configuration settings for that app. The Linux or Mac machines are more transparent. Windows keeps its own registry database. It's more difficult to work. When we change our Matlab options, last time I had you go through some of the settings in Matlab preferences. So we changed the tab settings and the backup files. Those settings are kept based on wherever Matlab wants to keep them. Okay? In this case, Matlab stores your settings in a file in your home directory. As soon as you say OK on that preferences window, Matlab updates that file so that the next time you start Matlab, it's going to read from that file to recover which settings you want to have, where you don't have to repeat your preferences every time you start a new Matlab window. Every program that you run on your computer is taking some memory, and the operating system keeps track of the programs that are currently running. Sometimes the programs can be unresponsive, and you need a way to sort of stop them. If you click on the X icon on the top right of a window, that would close it. On a Mac, you have the menu icon to quit an app. Sometimes the app doesn't want to quit, or it's unresponsive. It's busy doing something else. It is not able to respond to your request to close it. So we can kill it externally. On a Windows, we can open the task manager using Control-Alt-Delete key combination, or right-click on the bottom taskbar and select Task Manager. You may see a summary view. You can say, show me the details for these processes. And you will see the list of programs that are running currently. You can highlight one and kill it if you want to kill it. Again, this is something that you shouldn't do unless you know what you're doing. There are some of these that would prevent your computer from running properly. If you know that you were the one starting an app, such as, say, Matlab, and Matlab doesn't respond to me anymore, I can select Matlab and close it. When you expand this view, Matlab actually has sub-processes that it is running currently, but killing Matlab will kill all of these. Sometimes, all of a sudden, the fan goes on and your computer starts getting hot and it doesn't stop. That's usually due to one of the apps running constantly, and that may be because it really does need to run, and sometimes it may be due to a bug in that program. The software that we have installed are not perfect. The programmers who write these programs can make mistakes, and they do, and those bugs can cause unwanted behavior. If you sort your apps by their CPU usage, that's how much of the processing unit, the CPU, is currently being in use by that program, you can get a sense of how busy the CPU is being kept by each program. So right now, my Zoom web conferencing tool is using 10% of the CPU. What that really means is, say, out of 60 seconds, this program is running on the CPU for 6 seconds. So CPU, you can't really have 10% of it physically. It's sort of a time scheduling issue. The operating system takes one app, lets it run on the CPU, takes it out, lets another app run on the CPU, or run the instructions for another app on the CPU. And this happens very fast when we sort of look at the frequency or the ratio of the times that each program is running its instructions. That's reflected in this percent CPU usage. If there's a suspect program that is keeping your computer very busy and your computer is unresponsive, you can detect that, you can identify which app that is and kill it if you'd like. Killing can be done by saying end task. On Mac, you don't have this interface. Instead, you have a program called Top. I'm not running on a Mac, so I don't have that program. When you say Top, you will, in this black window, get a list of programs that are running and their CPU usage and their memory usage, using a command prompt called PS, which is going to give you a similar information. So that's the command that's currently running, except I don't really get the CPU usage information, but what I do get is process ID. Every time I start a new app on my computer, it gets assigned an integer identifier, and that identifier is how I can refer back to that program. If I want to kill this program from a command window where I can't really use a mouse and to select it, it's just text, I have to use another program and say, that's the process ID, 3056, please kill it for me. On Windows, there's a program called test kill, where I would say test kill /PID 3056 would kill that process if I wanted to kill it. Okay, so that's equivalent to making a selection in this window and hitting end process. So for almost any action that you can make using your mouse in an app, there's an equivalent command that you can run in the command window to get the same action. On a Mac, the program is called Kill. Again, you should really have to use it. When your operating system is not responding, you move the mouse and the mouse is very slow, you can't really do anything. There is sort of a universal way of restarting your computer. If you hold on to your power button on your laptop for 10 seconds, that's going to shut it down, and then you can restart. So now let's look at the types of files that I have on my computer. In this folder, I have a PowerPoint file. I have a text file. I have a text.bak file, which is a backup file that my editor has created. Index.txt file, which is a text file. add.amb.m, which is .m is an extension of a file name. .txt is an extension of the file name. If you are using Windows, you have to make sure that file name extensions is shown to you. Otherwise, what you see is not really representing the actual file. We want to be able to see .m versus .txt. These extensions are used by the operating system. When I double click on this, the operating system on Windows in the registry database, there's an association that says, anytime somebody tries to open .m file, go and run Matlab program and let Matlab program open it. Anytime I double click on the PPTX, there's an entry in my registry database that says, anytime somebody tries to open a PPTX file, run PowerPoint and let PowerPoint open this file. So opening a file really means letting an app run it, and that app would open the file. Files are not executable, meaning if I did not have PowerPoint installed on my computer, I cannot really open this file. So just having a PPTX file doesn't mean I have PowerPoint, doesn't mean I can view this file. I need to have PowerPoint installed, which is an executable. PowerPoint app is an executable, my computer can run it, whereas PPTX file is a data file that I have created that needs the PowerPoint app in order to be visualized. Similarly for .m, the fact that I have a .m file doesn't mean I can open it and start coding it or run it. I need the Matlab program installed, which can open this file and let me go through the code step by step. So that's executable versus data files. The executables have conventional extension of .exe. So this is where I have installed Matlab, and one of the files is matlab.exe. Exe is a conventional extension that represents that this file, when I double click on it, it runs by itself. It doesn't need to have some other program run it for me. Okay? So this exe file itself contains instructions for how it behaves. Each file is something that I should be able to open and read. It's composed of characters. So let's use Matlab to view the contents of a file. I'm using Matlab's editor just as a way to look into the contents of any file. I'm going to drag and drop matlab.exe into the editor subwindow in my Matlab. So right now I have opened matlab.exe. It's composed of characters. Most of these characters are sort of weird. They are not alphabetical characters. Each of these squares are actually a different character. That's because we don't have a way to represent them. There's no conventional representation for them. Matlab just displays a box for each one. If I modify this file and save it, that would break my Matlab app. So don't do that. All right. Executable files are what we call binary files. Anytime you see a file that contains these weird characters, we would call this file a binary file. It's not intended to be read by us. It's intended to be read by another app or by the operating system. We may be able to read some parts of it, like this one, but for the most part, it's a binary file. There's going to be some shorter text, usually at the beginning or at the end of these files, that we may be able to read, such as Symantec Corporation here, but the rest of the file is binary. So let's now open another file. Let's look at a PowerPoint file. Do you think that's a binary file or a text file? When we look at a PowerPoint in our PowerPoint application, It contains text, right? There are things that we can read. But there are also things that are not text, but are related to this file, such as what color I have this in. When I make it red in the file, that needs to be represented somehow. And the way that it's represented is left up to PowerPoint to decide. And what PowerPoint does is it takes all the slides that you've written and their formats, their colors, sizes, and all of that information. It writes it in a binary file. That way, when it's rereading that file, it has both text and all the formatting information available. You can take a data file and write it as text or binary if you'd like. That's a choice that you can make when you are writing your own programs that will work with external files. Typically, reading binary files is faster than trying to read complex data from text files. Dragging and dropping PPTX into Matlab window and looking at the contents of this file. And again, it's a binary file. For the most part, we cannot read it. Now let's look at the notes.txt, which is a text file. It's not binary. Every character is an alphabetical character or has a visual representation, and we can read it. .m file is, again, a text file. We can open it and read it. That's the distinction between binary file and text files. Text files are composed of characters that have visual representations, whereas binary files can contain characters that have visual representations, but also contain characters that really are not intended for any visualization. The MATLAB that we're going to use is an interpreted language. What that means is we write our code, and the MATLAB app goes through that code and runs it. So MATLAB interprets the code that we write, and MATLAB is the thing that's actually running on the computer. A compiled programming language is where we write our code, such as in C, C++. You write your code, and then you need an app called a compiler, and you produce an executable from it. So when they wrote the MATLAB app, they actually wrote it in C, C++. They used a compiler to generate matlab.exe. And now this compiled exe file can be executed on the computer without needing any additional software. There's a dependency on the operating system, so if you compile a program for Windows, it will only run on Windows. If you want it to run on a Mac, you have to recompile it for that target environment. But in order to run an executable, say at anb.exe, if I write a program in C++ and compile it, I can share this with anybody, assuming they have Windows, they'll be able to run it. They do not need the compiler installed on their computer. Whereas in this class, we're going to write M files. We are not compiling them, although there are ways to compile M files as well, but we're not going to do that in this class. If you take this file and move it to another computer or share it with somebody, they need MATLAB installed in order to rerun this file. So MATLAB goes through this file and interprets it. Therefore, we need MATLAB installed on the computer in order to run the contents of an M file. When you are given a problem, the problem description can be translated into a programming language. Pseudocode is sort of a semi-English way of describing the problem. Let's assume that we are solving the add A and B problem. I would say declare a variable C, store A and B into C. So for each step that I'm going to write in my code, I can write in short English sentences what I'm going to do at each step. And this collection of English tasks written in English or any other language that you want to write in is called the pseudocode for my program. When you solve a complex problem, it is recommended that you write out your pseudocode first. That way you can go through and step-by-step translate it into your programming language. And we're going to do that as the problems get more complicated. We're going to write our pseudocode first to make sure that we can state our implementation in English first, and then go through each task, translate it into MATLAB code. The source code is the code that we learned to write in this course, so that's going to be our MATLAB. Machine code is if we were to compile our source code either C, C++, or if we use M and use a compiler, which we're not doing in this course, and generate an executable. That executable is given in a machine code language. When I open that exe file, matlab.exe, this is in machine code. So every 8 characters represent an instruction that my operating system will run. Every chunk of characters contains some instruction that the machine understands and runs. Modifying the machine code is not really easy, and we typically don't do it. Assembly language is sort of one level above the machine code. It may still look cryptic, but the instructions have conventional codes, and we can read them and write them more easily. All right, so this is a program written in assembly code. Those are the name of the instruction. A 3-letter code representing what that instruction does, and an argument for that instruction. For example, jump says go to somewhere else. And by changing these numbers, you are changing the instruction, you are changing the arguments. Some people write their code in this way. Why would they do that? Are they insane to go through that difficulty? The advantage of using assembly language is that they have more control over precise steps that are being executed. If you have an operation whose speed that you are really concerned about and you want to optimize it, you want to make it run as fast as possible, you can write that code in assembly language. When we write our code in, say, Matlab or C++, the compiler tries to optimize things, but it cannot do a great job at it. It will convert into an assembly code and then to a machine code, but that code will have some overhead. Going into assembly language allows us to optimize a program and have it run more efficiently. Bytecode is somewhere in between. Programming languages like Java and even Python, they use bytecode. Is Python a compiled or interpreted language? When you're trying to answer that question, you have to think about, if I have a Python file, can I run it by itself, or do I need to have Python installed to run it? If you need Python installed to run it, that means it's an interpreted language. You need Python app to interpret the program that you wrote. When you run Python and have it execute a Python program that you wrote, there is an intermediate step that Python takes. Convert your file into a file with the extension PyC. PyC is a binary file, whereas your .py file is the code that you wrote. You can open this and read it. You can open it and not be able to read it. And then Python will run through the instructions contained in this PyC file. So there's some process that needs to take place to understand the code that you wrote, where the selection statements are, what variables you have, what are you trying to store in those variables, and things like that. That needs to be done at least once. And Python doesn't want to do it every time you run that Python code. Therefore, it's going to create an intermediate file for that Python file and go over that next time you are running the same code that you wrote.